Good morning, everybody. Welcome to a CFES webinar. Very excited to host Anjay Schmidt this morning. We have been in collaboration with some of our school partners and our college partners, but this is a really special event. Beekmantown Central School is hosting the NASA data downlink through the space station in partnership with Plattsburgh State and the Shine On organization. Have to give a big shout out to Shine On and all the students in their organization, along with Dr. Colleen Lemza, who put the application together to host that data downlink at 10:30 today. We're going to kick off their full day event with Anjay Schmidt. Anjay is an JPL solar ambassador and a pilot with NASA. He's done 2 analog missions, which he's going to share and give you insights about that. The really neat thing today is to get a perspective from someone who's lived the experience of what astronauts go through in space, all the research that goes behind missions, as well as some of this experience with SpaceX Mars rover, and also to talk about teamwork and all the essential skills that go into putting a mission together. And the number of people and the careers and what people can do to support these type of space exploration. So I'd like to introduce Anjay, and he's going to give us some of his insights on his pathway, what led him to NASA, and some of the things that he does. Welcome.
Thank you. Good morning. How are you doing today?
I'm doing great. Oh, before you jump in, I want to tell our students, if you do have questions, please put them in the chat. And we'll try to answer as many as we can as we go through our conversation. Anjay, thank you.
Absolutely, thank you.
So can you give us some background on your pathway, as from a young person and aspirations and setting goals going all the way to where you ended up at the Johnson Space Center in Houston, Texas?
Certainly. I mean, it's definitely been kind of a long road, and it wasn't sort of a straight line to NASA, to be fair. I know, started when I was very young, watching certain television shows, kind of got the idea that I thought that traveling to space would be a really cool thing to do. Originally wanted to go to the Air Force Academy for college. Late in the game, kind of changed my mind. Decided I wanted to do something a little bit more academic, so I ended up going to the University of Texas at Austin instead, studying aerospace engineering when I was there. From there, spent a couple of years at MIT doing grad school work, got my master's there, and then from there entered sort of a series of jobs. Started at Draper Lab in Boston, Massachusetts, doing design for the US Navy, and also doing some NASA work there too, designing sort of a cockpit design for a lunar lander. From there, I moved to Lockheed Martin. And so that took me down here to Houston, Texas, where I was working design work for the Orion spacecraft. We'll come back to that in just a minute. Because from there, I went from design work into flight operations, which is kind of sort of my real sort of passion. Is not, I'm okay at designing, but I feel like I'm much more of a pilot. So I'm moving into flight operations, where I was a flight controller for a number of spacecraft, some around Mars, the Spitzer Space Telescope, the Juno mission out to Jupiter. And so a lot of interplanetary missions, and finally getting to send commands to these vehicles and fly them. Had a bit of a break in there where I went and did first a 2-week analog mission and then a year-long analog mission. So getting to experience what it's like to be an astronaut, traveling to some of these more distant destinations, and then finally coming back to the Orion program as a flight controller now at Johnson Space Center, which is where I'm at right now. At the same time, sort of started sort of a side career as a test subject as well as part of those analogs. So I'm still doing a lot of test subject work here at NASA as well, getting to test some of the technologies that we'll be able to use with astronauts going out into space as well.
So can you touch base a little bit on the Orion program? What exactly is that? And obviously, if you could go into a little bit more depth about the testing, what you experienced to help support future, space launches. And we'll get in a little bit about, obviously the space station.
Certainly. Sorry, the first part of that question was, sorry, repeat again. Just
the Orion program.
Yes, the Orion program. So what Orion is that's kind of NASA's next space capsule that they're designing along with Lockheed Martin. And the idea of this is it's supposed to be a capsule that takes us out to deep space destinations. We kind of originally worked up to the Apollo program, which got us all the way out to the moon. And then our next spacecraft that we use, the Space Shuttle and the International Space Station, kind of brought us back to Earth orbit. And we spent about 30 years doing a lot of good work in low Earth orbit, but now we're looking beyond that again. And so Orion is supposed to be the capsule that in the near term takes us out to the moon. And so we've got a test flight hopefully coming later this year. If you hear of the Artemis series of missions, that's the set of missions that we've got set aside for this particular capsule. And the next one is to first take the capsule itself out to the moon and test it. And then if that's a good flight, the flight after that, we'll have people on board and take them into orbit around the moon.
Okay. So I know you have some things you're going to want to share with our students. We do have a quick question from a student. Do you have any idea how much the space station weighs?
How much it weighs? If you take all the components, and this is a bit of a question because in space, things don't have weight. Well, okay, that's not entirely true. Things still have inertia.
They have mass.
They have mass, and there's still a force of weight acting on them. But if you were to put try and put the ISS on a scale in orbit, you wouldn't measure anything because the scale itself would also be floating around the Earth as well. But I believe if you were to bring all the components down to Earth and weigh them, I think it's something on the order of like 1 million pounds or so. It's a possibly the largest space vehicle ever assembled in space. It's absolutely gigantic. It's very complex as well. The way I put it, it's kind of a spacecraft that eats other spacecraft. It's built of all these little modules, and a lot of those modules on their own are complex enough to be their own spacecraft.
Okay. So an analog mission, one of the things that the students, what I'm hoping the students learn from this is the complexities, but the complete collaboration that everybody's involved for something like to put the space station in place, or your next, the Orion mission where they're going to go back to the moon and maybe farther. Talk about what your analog missions are like, and how does your experience help future flight exploration?
Sure, and if you don't mind, I can go ahead and show a couple of photos so I can at least kind
Absolutely.
of let people see kind of what these analog missions look like as well. So let me go ahead and share slides. So these are the facilities that I stayed inside. And so they're designed to kind of replicate what it would be like to be inside a spacecraft. The one on the right it's called the Human Exploration Research Analog, and that's sort of a mouthful to say, so we just call it HERA. And that's sort of, I'd say, a short to medium duration sort of facility where sort of test subjects now are staying in there up to about 6 weeks. I spent 2 weeks in there on one of the earlier missions. And then the facility on the left is more of sort of a longer duration place. I spent a year there. And that's more kind of to simulate a Mars mission. So if you look, it's kind of on that barren lava rock out on the Mauna Loa volcano in Hawaii. And so you go out there and here's another picture of it. It's very barren. It looks like you're on another planet. And we do a lot of things to simulate a lot of the hardships that the astronauts would go through as well. So the whole idea is it's not in space, but it's kind of simulating certain aspects of that space flight to study the effects of those things. So for example, we're still on Earth, we're still in a 1G environment, so we're not necessarily studying the physical aspects, but what we can do is study the mental aspects. So being in a small confined space for a long time, seeing just a few other people over the course of the year. So my crew members were the only people I got to interact with. directly over the course of that mission. And so it's trying to simulate certain aspects of spaceflight as accurately as possible, and then being able to study those, if that makes sense.
So what are some of the experiences? Obviously, not necessarily the physical experience. So, you know, when you didn't lose muscle atrophy, you were able to, you know, all the things that happen to astronauts in space. What are you doing? What happens to an astronaut in that isolated space for a year? I mean, I think our students understand you never left that bubble for a year. Okay,
right.
So you were really in isolation with your crew members,
Yeah.
and you had to do a lot of research for the scientists who were trying to determine what are the experiences going to be so we can support our astronauts when they actually do go into space.
Right, and I'll pop to this slide here because this shows kind of some of the things were doing. For us, we were kind of the science experiment. Most of the time, whenever we're sending astronauts into space, they're studying other science experiments. Occasionally we study them. For us, we were the science. But that being said, we did a lot of things that astronauts would do. They refer to them as flight-like tasks. And what that means is we're kind of doing the same sort of science experiments and the same sort of housekeeping tasks that the astronauts would do. But instead of us doing those to achieve those science goals, we might be doing that too. But what the scientists are really doing is they're measuring us. They're seeing how well we do those tasks. It's not necessarily to grade us or anything like that. It's to see if the stresses of the mission are affecting us. So are we getting better at these things as we keep doing them and learn how to do them? Or are the stresses of the mission getting to us, and are we starting to slow down? And so what NASA was trying to do is to study those aspects, see if there were ways to detect problems before they started to arise. And then if problems did arise, trying to come up with techniques and technologies to kind of help mitigate those problems.
So as the science subject, what are some of the things that did occur? I mean, our questions are starting to populate here a little bit, but what can you tell our students what are the astronauts going through in the space station that physically, emotionally, mentally, the challenges that they have to overcome? We talk a lot about perseverance at CFES. Obviously, what are they persevering through in this isolated capsule?
I mean, it's definitely kind of a very different environment. It's, as we've mentioned, you're inside this sort of small enclosure with a small group of people. And they're people, everybody's there because they were selected for being really good at the job, if that makes sense, but not necessarily because they knew each other ahead of time. And so there can be interpersonal stress as people are learning to work with each other. Being in Hawaii, we did kind of get seasons, but whenever you're up on the space station, there's no summer and winter. There's, you see 16 sunrises and sunsets a day, so it can be very easy to lose track of time, and that can be stressful as well. We did experience that in Hera, where we didn't have any windows. We just kind of were in this enclosure for 2 weeks. And especially at the beginning, I found it was very easy to lose track of time. So I kind of had to force myself to keep my eye on my watch. Otherwise, I'd lose track of where I was in my day. Even in high seas, we made sure that we took the time to observe holidays and things like that, only because that kind of kept you grounded. It gave you sort of an idea of where in the year you were. I mean, if you were sort of celebrating Christmas, that made it feel more like you were in winter. So there were a lot of those stresses. One thing that astronauts going to Mars will have to deal with as well is communication delay. So whenever you're out on Mars, you're far enough away from Earth that you can't just pick up the phone and talk directly to Earth in real time. The signal has to cross space. Yeah. And even at the speed of light, that signal still takes anywhere from 3 minutes to 22 minutes to get to Earth. And so there's a lot of disconnect with your mission control team, with your loved ones at home, just because you can't just sort of have a conversation in real time. And you lose a lot of like nonverbal cues whenever you talk as well. So whenever you talk to somebody in person, it's not just the words, it's sort of body language, how they stress certain words. All of this conveys information, and a lot of that is lost in a radio signal. And so it's very sort of difficult to keep in contact with home. The flip side of that, though, is whenever you're in an environment like this, it's very focused. And that's because it's so hard to communicate, a lot of the distractions are sort of taken away, if that makes sense. So
Sure.
you're not having like news or YouTube or things like that. It's a much quieter experience. I kind of equate it to being in a monastery, you know, like Shaolin monks, being able to be in this very sort of quiet, very almost meditative environment where you can focus on the thing you're doing without any distractions. So it's got some upsides as well, but it's, again, a very different environment.
So when you're simulating this mission, the kids have a few questions like, you know, your eating pattern, you know, obviously got to coordinate time. Do you eat the same things that astronauts do so they can monitor health, and or if you get sick, you know, what is that experience like? You know, you're certainly not, you know, ordering in from grab and go or whatever those, you know, McDonald's or whatever.
Yeah, well, especially the food and illness, I'll talk about a little bit as well. The food itself is, it's not as bad as you think it is. It is a little different. So I'm showing a couple of photos of that here. For hair, we actually did eat the same food that the astronauts eat. And so it's a lot of things like freeze-dried foods or vacuum-packed foods. For the freeze-dried stuff, they come in these plastic packages like the shrimp cocktail on the top right, and it kind of looks and feels like styrofoam. And you add water to it and it sort of becomes food magically in front of your eyes. And this sounds very weird, and it is. I mean, you're kind of cooking food with a syringe full of water and just sort of adding water to foods, and that's how you cook. But the foods themselves, you know, back in the early days of the space program, the food was really bad, especially during kind of the Mercury and Apollo missions. We've had a long time since then to get it right. And so a lot of the food's really good now. Oh, excuse me. Sorry. But there's
scientists who create food for NASA. That's a career.
Absolutely. We have a full sort of astronaut kitchen, and they're developing new foods for astronauts. One thing we found with the Orion capsule is it's much smaller than the ISS. And so we're trying to develop these meal bars at the moment that are sort of very calorically dense just because they take up less space, so we can store more of them aboard the vehicle. But we're trying to get them so they're still palatable so the astronauts will eat them. So absolutely, we have people who study the food that the astronauts eat at NASA.
So I want to jump into a couple more questions. You talk, well, they're asking, what happens when you got sick? How was that managed?
Illness. So we actually didn't get sick. The nice thing about being up there is, I say we didn't get sick. I got a little ill a couple of times. I'll talk about those, but things like colds, flus, things like that, these are all things that are passed through viruses or bacteria, and you can't catch them if you're not exposed to them. And so being isolated on that mission, we never encountered anybody that had a cold or had a flu. And so we kind of had a year without viral illness. So it was, I know a lot of people with the pandemic have been in quarantine or isolation over the past year. We were doing isolation well before COVID. So it kept us sort of isolated away from diseases. That being said, I did get sick a couple of times. I got something I ate didn't sit well with me one day, so I had a stomach ache one day. And then the other thing that happened was while I was up there, I wanted to make sure I was vaccinated correctly before I came back to Earth. And so they were able to send up a Tdap vaccine. And just like people are having sort of, you know, feeling ill the day after the COVID vaccines, while their body sort of reacts to it and creates the antibodies it needs. Right. My body did the same thing after that. So I had sort of an afternoon after I got that shot where I just kind of felt a little bit unwell while my body sort of adjusted to it.
So there are a few questions here, but I do want to ask a couple of relevant questions. You know, we spend a lot of time working with our kids in our CFES program about essential skills. The there is a question that I think would relate to perseverance is, does anyone have difficulty, mentally adjusting to the new environment? When you leave the isolation and you come back to basically civilization, do they monitor your, psychological aspect when you're done? I mean, obviously it's got to be a struggle. You got to persevere through it for a year. Mm-hmm. What about the transition?
And that's an excellent question. It's not one a lot of people think to ask about is, whenever you go on a mission like this, you understand that what you're doing is very different and very new and very unique. And so you're kind of ready for the shock of moving to this whole new environment. I mean, that's not to say it's not stressful. It certainly is, but you're kind of at least sort of prepared for that it's going to be different. But coming back, which a lot of people don't realize until you've done it for the first time, is you kind of have to do that in reverse. You kind of have to relearn your routines that you had before. And at least for our analog missions, that hasn't been sort of studied as much, but it's definitely a factor too. For my first Hera mission, our commander, Ethan Good, he spent a lot of time down in Antarctica prior to joining NASA. And he told us, whenever you get out, look both ways before you cross the street. And he wasn't kidding, because there are people who've come back from Antarctica, for example. You've spent 6 or 7 months not having to cross a street and you forget how to do it safely. And to be fair, I went out shopping and almost got run over in a parking lot because I forgot that I need to be looking for cars. I was just kind of walking back to my car and not looking around because it had been months since I had done that.
There's a big psychological aspect.
Yes.
At both ends of the spectrum, in the isolation and coming back. Wow.
Absolutely. And they've even, they have studied this because they have people in military coming back from military deployments going through this same sort of transition back to normal life again too, going from a very high stress situation, coming back to sort of the normal world again. So it's something that's applicable beyond space flight.
This is kind of a neat question from the 5th grade at Beekmantown. You talked about being focused. Mm-hmm. And obviously you're there, you're doing your goal setting, you got a mission. At some point though, did you have fun? What did you do for fun? Did you play cards? Did you, what kind of things do you do for fun?
There we go. Yes. And that's actually important. And so you think of astronauts being very sort of accomplished people. And whenever you're seeing pictures of them, they're all doing very good work for NASA and things like that, but they're just like anybody else. You can't run anybody 24 hours a day, 7 days a week. Like sooner or later, people have to collect themselves and do something that recharges them. In Hera and High Seas, it was a very short mission, so it's kind of just a lot of books, a lot of movies. For High Seas, we're able to take a few more things. They don't have any board games on the ISS. I think they might have like a magnetic chessboard up there. But you can't have a full stack of board games because the pieces will fly. But we did have board game nights on simulated Mars. We had movie nights. We even had a crew member who knew how to salsa dance and taught us how to salsa dance. The thing I noticed kind of about my crew members, we weren't told that this was something we had to do, but I noticed that my crew members were kind of very driven folks who liked learning things. And so we had crew members who were learning languages. Cyprian there, he's got that little ukulele. He had never played uke before. So he learned how to play that while he was in there.
Another good question. For the astronauts, if they're up in the space station, how do they work out? Obviously you got to be mentally fit. That's what a lot of your study was, but how do they stay physically fit without any resistance in space?
It's certainly a challenge, and it's something that's still kind of an active area of research because whenever you're in orbit, you're not using your arms and legs as much. And what your body does is realizing that it's not using them, it doesn't maintain them as well. So after a while, your legs, the muscles in your legs become weak. Your bones can start to become weaker as well. And so NASA makes the astronauts work out up to 2 hours a day. And it's a daily thing to try and counteract that. And so we've got a treadmill. You might wonder how you'd run in space. but we have a treadmill and sort of like a spring harness system that kind of pulls you down onto it. And they've got a sort of a stationary bicycle. And I've actually had a chance to test the most recent version of that they're getting ready to send to replace the old one. And they do have sort of it's kind of like weightlifting, but they've got sort of like a weightlifting bench. Instead of weights, it's, again, springs and bands to sort of simulate that, the resistance that a set of weights would give you. So they do have kind of all these exercises that they can do, and it is very important that they work out every day.
Yeah, it's a good mental and physical have to come together. You mentioned they're sending up a new stationary bike. Explain to our kids, how do the people in the space station get materials and supplies?
It's all rockets, and the thing about a rocket is you're limited by weight and volume as well. So it's not like you can kind of send anything you want. You have to send things that will survive this space environment, that will survive the G-forces of launch, but it is sort of occasional. So it's not like you can just kind of step outside the airlock and go to your nearest general store or your nearest grocery store to pick up supplies. You get supplies kind of on a set schedule. And so there's actually a lot of tracking of things on board. There's a whole console position in mission control, ISO, and their whole job is to keep track of inventory on the ISS. And in part, that goes to planning what's going to go on the rocket a couple of months from now to go resupply the station.
So we're talking a little bit about the experience that you had simulating what the astronauts are going through with the ISS. How about, can we shift gears a little bit? A large part of your job is working at Mission Control in the Johnson Space Center.
Yes, sir.
Kind of talk a little bit about all of the people and the careers. Like when you and I had our first meeting, you basically use the analogy that the astronaut is the tip of the spear. But everything from the point of the spear all the way to the end is the entire teamwork and the collaboration and all the different skills required so they are successful up at the space station. Can you touch on that a little bit? Your job at this Johnson Space Center and what you do at Mission Control, but also if a student wants to say, I'd like to be part of NASA, but I don't know if I have the math skills to be an aerospace engineer like you, what can they do?
The short answer is there's a whole lot you can do at NASA. The engineers are the ones that kind of get the visibility, but we've got a whole host of jobs. We've got lawyers, we've got artists, we've got public relations specialists, we've got people working human resources. So there's a whole range of careers that are available at NASA. So just because you're not, as you said, sort of the typical engineering or science person doesn't mean you can't work at NASA. There might be a different job that's available, but you had touched on sort of the astronaut as the tip of the spear. And that was something that just the perspective that getting to go on one of these missions gave to me was I've always kind of been a part of one part of the aspect of the mission, kind of looking upwards towards that, being at the top of it and seeing everything that goes on. It gives you sort of a respect for how much goes into one of these. And to kind of give you the idea, before you go on a mission like this, you go through a lot of training. And part of that training is for each experiment that you do, there's a scientist and maybe a research team, and they're focused just entirely on that one experiment that you'll do. And so they'll come and they'll talk with you and teach you how to use their equipment and tell you what they're looking for. And you realize that they're focused on, for them, that's their whole job. And for you, it's this one thing you're going to do for 20 minutes, 3 times during the mission. And then the next person comes and teaches you there. And after a while, you realize you're kind of, again, at the tip of the spear here. And you've got all these other people who are relying on you to get their experiments done. And they're supporting you. You've got this whole organization, and each kind of group is focused on their little piece, and you're where all the pieces come together. And you get this sort of view that there are dozens to hundreds of people focused on what you're doing. And for the astronauts, it's even more so. It's hundreds to thousands of people. and they are sort of the collection point for all of those people's work. And you get to realize just how much goes into a mission like this. Does that kind of cover that?
Yeah, I think that, one of the things, as a former principal and science teacher, there's always been this affinity of space travel, and kids are always intrigued about outer space and how do you get there and what do these people really do, and and you could be part of the team, even from we had another person from NASA speak in the fall. They talked about the value of people putting the electrical circuit boards together. If you're the person soldering, you may only have to have a certification through NASA and a high school diploma, but you're really part of the team. I mean, one of the questions came up is, how does electricity work in space? I'm assuming it's battery powered.
It depends on the vehicle. Most of at least anything in Earth orbit is using solar power. So the space station has these enormous solar panels that's using to generate electricity, and part of that's getting put into battery, because as the station's circling around Earth, it goes behind the Earth and into shadow once every orbit, and so it has to draw from those batteries to stay powered up. Right. But yeah, it's a lot of solar power. As you get farther into the solar system, so for any mission that we've ever kind of sent past Mars, except for one, we've used what are called radioisotope thermal generators. And so they've got a piece of radioactive plutonium, and as that plutonium breaks down, it generates heat. And so that's how we powered the Voyager spacecraft. Even our newest rovers on Mars are powered by these. And I say there's one mission that hasn't. There's a spacecraft at Jupiter called Juno, and one of the significant things about that mission, it was the first mission that we sent past Mars that used solar panels. We had gotten to the point where the technology on solar panels was finally good enough that we could power a Jupiter mission with them. That being said, there's still enormous solar panels on that vehicle.
Yeah, wow. So all aspects of energy used to propel, our missions. How long did it take for the initial satellite, the International Space Station, how long did it take it to get in space and into orbit? What was the time from launch to orbit? Do you know?
I don't know the exact one for that. I know for the space shuttle, launch from pad up to at least initial orbit, not necessarily to the first ohms burn, but at least to the point where you'd say the vehicle was in space, was 11 minutes. Okay. And a lot of that is, it's not 11 minutes to get to altitude. It's a couple of minutes to get to the right altitude, but then you spend the rest of your time speeding up. Right. So orbit, people think space is high, but it's also fast. Yes. So it's, once you get to orbit, it's about getting enough speed to essentially, once you turn off your engines, you're falling, but you've got enough forward speed that as you fall, the curvature of the Earth is falling out underneath you, essentially. Right.
As a retired physics teacher, I'll tell our kids, everybody should take physics, because then you're going to know exactly, the forces, the gravitational forces, and, the amount of speed it takes to stay in your projection. And it's really awesome and neat stuff.
I'm going to step away for just a second so I can close the window here. I realize I'm getting kind of the sun through the window. Probably just a second here. There we go. That'll be better.
Sun's coming in. So, one of the things kids, obviously our students have a lot of questions like normal life, how do you sleep? And, all those things, we talked about the hydration, using the water, syringes to food, what is the most significant difference in being in space as compared to having a regular life on Earth? What do you think the most significant difference is?
So it depends on which part. If we're talking about like the stuff I've been through, you're kind of having to do everything, if that makes sense. And that includes things that you may not be trained on. The big example I bring up is haircuts. We haven't set up, at least not that I know of, but we don't take barbers and send them to space. We take astronauts and train them how to cut hair, if that makes sense. And so there's all these sort of little things that you may not think about, that all of a sudden you have to learn skills, and not like engineering skills or science skills, but just kind of everyday housekeeping skills that you have to do.
Right.
Now, I think if you were to ask an actual ISS astronaut, the biggest challenge would be the lack of gravity. That there are certain tasks that are just made harder by the fact that things don't want to fall in a nice orderly fashion, that you're now having things complicated by the fact that things are floating around now. And that seems like it'd be fun, but there's also difficulties that come from that as well. Let's say you're having
to hook themselves onto things so they don't move, like as if they were a rock climber.
Right. Because Newton's laws are in effect in orbit. You know, if you apply a force to something, if you're not tied down, that thing applies a force right back at you. And so you can't just sit there and turn a wrench, because the wrench will turn you as well unless you're tied down.
Right. Yeah, that's very interesting. That would be a cool thing for our kids to experience, even though they won't. But the concept of just basic Newton's laws and how they have to be corrected in space as applied to the gravity on Earth, what a neat experience. I know we have a couple more questions, and I think we're a little bit over our time. I'll see if I can if you're okay with that, I'll scan through some of these.
Sure.
Temperature in space. What kind of temperatures? Obviously, in the ISS, the temperature is probably regulated, but what is the temperature?
So temperature is hard to say. It's in part because in order for something to be hot, it has to be there. So air is hot because there's molecules, and those molecules are vibrating at a certain speed. And so in space, which is a vacuum, space itself doesn't necessarily have a temperature because there's nothing to be hot, if that makes sense. Yeah. But as far as surfaces on the space station, I forget the exact numbers, but I think it can go from anywhere like negative 250 degrees on the shaded side to positive 250 degrees on the warm side. So, and so that's part of the challenge of designing a spacecraft, right, or a spacesuit, realizing that, you know, an astronaut's out there in a spacesuit and they've got something like a 500-degree temperature gradient between their front side and their back side. And so things get either very hot or very cold, depending on whether they're in sunlight or shadow.
Right, and then the material itself, as it changes the temperatures, the contraction, expansion of the material, and making sure that it's stable. Wow. One of the questions there was one that I really wanted to see here. You worked on SpaceX, and you've talked about work with Mars. What's the biggest shuttle that you've ever worked on?
The biggest mission that I've ever worked on, size-wise, I think was Juno. And Juno was a large spacecraft. It's hard to, I don't remember the exact sizes. I've trained on ISS systems, if only because any flight controller that goes to Johnson Space Center at the moment trains on ISS, not necessarily because they're going to work that, but that's because kind of all the training materials are currently built for that vehicle. Right. And so we at least sort of get a initial flight controller training on International Space Station before we go on to whatever vehicle we're going to use. So I've trained on it, but I've never actually done anything directly with it. I'd say once it goes, Orion will probably be the largest vehicle I will work on once it flies. But the one that has flown so far, I think Juno's the largest one I've flown that's actually up there right now.
Okay, I know we've gone over time. My last question always is, what advice can you give our students, you know, to aspire to meet their goals, you know, if they have interest in, you know, working at NASA or being something like this, or just in general, just to attain your goals? What advice can you give our students who are participating today?
Oh boy, there's a bunch I could give. The one kind of piece I'll give right now, only because I've had a couple of other people I know that have had this advice recently too. Success isn't about winning. You know, it's the people who are successful and get to do the cool things aren't the ones that got lucky and succeeded at everything they did. Sooner or later, you're going to hit something and you're not going to succeed. You're going to fail. and that's okay. What I say is success isn't about winning all the time. It's about what you do whenever you fail. Do you pick yourself back up and keep going? Do you, find a way to tackle the problem in a different way? Or do you realize that maybe this isn't the path you need to be on? Maybe you need to be on another path. The way I say it is, people view their way through life as a path, and most people's lives are not a straight road. And they take twists and turns, and sometimes you hit roadblocks and stops and things like that. And if you look, the people, at least at NASA, who've been able to get here and be successful here, are people that have, had to change course along the way. And it's having sort of the tenacity to be able to take those losses and still keep going. That's really what I believe leads to success.
That's great advice. Fall down 7, get up 8. Use your mental agility to solve problems. Obviously, you've done that your whole life. NJ, this has been an awesome experience. I know we went over a little bit, and there's still a ton of questions. I will look through these, and if possible, I can shoot you an email and try to get some answers to questions if you don't mind doing that on your free time.
That'd be fine.
Really, really appreciate you taking the time. For our students, it's an hour earlier in Houston, Texas. So, you started your workday pretty early, but this has been awesome. And to our partners, Shine On at Plattsburgh State, SAIC, and Beekman Town Central, who is hosting, thank you so much for giving our students this opportunity.
Absolutely. And I hope you all enjoy the uplink later today. It sounds like it's going to be awesome.
Yeah, I think it's very exciting. 10:30 this morning. Okay.
Awesome.
Take care.
You too. Thank you very much.
Thank you.